Okay, folks, last example for our kinetics calculations. And this is different than the other examples we saw. So this is kind of like all the different types of problems you could maybe see on the free response portion, hint, hint, of your exam. I can't even like wink without looking weird. Okay, nitrous oxide is used as an anesthetic and in aerosol cans to produce whipped cream. It is a potent greenhouse gas and decomposes slowly to N2 and O2. And here's the balanced reaction. Once again, we see a number 2 right there, but we have to tread lightly. We have to see what the data says about this reaction. So if the plot of natural log of N2O as a function of time is linear, what is the rate law for this reaction? Well, that's got to be first order because natural log of concentration versus time gave a straight line. So the rate law for this reaction, we could write like simply rate equals K times N2O, raised to the first power, okay? And of course, we could have also said, that's equal to negative delta N2O over delta T. Perfectly fine to just write rate equals this. So B, this one is a little bit trickier. How many half-lives will it take for the concentration of N2O to reach 6.25% of its original concentration? So we remember, for one, that's got to be 0.0625. And there's a couple different things that we could do here to make this work. We could do this ratio again, right, and figure out how many half-lives it would take by doing the algebra. We could also just kind of play around with numbers for a minute via the following. So we know at time 0, let's just suppose we have 1 molar, okay? Well, at 1 half-life, so I'll say 1 T1 half, we would have 0.5 molar. At 2 half-lives, we would have 0.25 molar. At 3 half-lives, we'd have 0.1225 molar. Let's make sure I did that right. 0.25 divided by 2. 0.125, I knew that looked off. And if we do one more half-life, let's divide this by 2. Divided by 2, we get the 0.0625. Okay, 0.0625 molar for 4 half-lives. So what if we didn't have this nice even number? Like, how would we do it? Well, there's a couple different ways. I'm going to show you what I think is the most straightforward based on all of the other problems that we've done. Okay, so for one, we recognize half-life is the natural log of 2 over K, or in other words, K equals the natural log of 2 over T1 half. We also know that if we want this to be 0.0625, I could assume that the natural log, or rather that the A at time t is 0.0625 and A initial equals 1. So now when we go to do our generic reaction, we can say that that's going to be, we know that it's negative K times T, right? So, and I'll write that down, negative KT plus natural log of A, 0. But now let's plug in everything that I know. So I know that this is going to be the natural log of 0.0625. I know that K I can replace with the natural log of 2 all over T 1 half. I could have put the 0.693 in there, but you'll see why in a minute. I kept it as natural log of 2. I can also now multiply that by time, and specifically, I'm going to multiply that by t. So we'll leave that as such, okay? And then now that's plus the natural log, of course, of 1, which we know that drops out to 0. I'm going to leave this as is, all right? And what you'll see here is if I do some math now, I've got natural log of 0.0625. I've got negative natural log of 2 over t 1 half, and the ratio of t to t 1 half is going to give me my number of half-lives, right? So let's write that down up here. If I have t over t 1 half, I'm just going to call all of that equal to x, because, right, if x is equal to 2, that means 2 half-lives. If x is equal to 3, that means 3 half-lives, and so on. So now that becomes natural log of 0.0625 times negative natural log of 2 times x. And we can do it. We can solve for x just based on those numbers right there. So, and that will go as the, so we'll just do the numbers, right? So 0.0265 natural log, 0.0625 natural log, and I get, this number here, negative 2.77 something, and that all equals, we know the natural log of 2 is 0.693, so negative 0.693 times x. And now if I solve for x by dividing both sides by 0.693 negative, then, that was not right. So 2.77 divided by 0.693 equals 3.9997, which you can see is our 4 half-lives. So if we did not have a straightforward even percentage like that, then we could set it up and do it in this algebraic way. Okay, that's the last of our examples, folks.